Hello, welcome back to Algebra 1. Today we're going to be going over topic 1.3. What this means is we'll be covering literal equations, rearranging formulas, and real-world applications. So in our previous lessons, we solved equations to find the numerical value for x. But today, what we need to do is solve for a variable when there are multiple variables in the equation. So we're going to be rearranging these formulas using real-world formulas that you'll see in science, geometry, and finance. So before we start this, let's go over one of the questions from the homework. So we have 3 times 2x minus 1 plus 6 equals 6x plus 3. What do we do first? Let's distribute. So we put the 3 into the 2x into the negative 1. So that gives us 6x minus 3 plus 6 equals 6x plus 3. So now what we can do is combine these two like terms. So 6x plus 3 equals 6x plus 3. Now what you can do is notice that both sides of the equation are the exact same thing. But just to show you, we can continue to solve. So let's minus by 3 on both sides. That gives us 6x equals 6x, divide by 6, divide by 6, x equals x. You should be really happy when you see this because you know if any side is the exact same as the other, you know the solution is infinite solutions. So another way to write this, if you want to be quick on a test, it's like this. That means all real numbers. All real numbers, which is the same thing as infinite solutions. Okay, so now we're going to move on to our actual topic for today. We're going to start with one you're going to see next year in geometry, which is the length the perimeter of a rectangle. Now, you know the perimeter is all of the sides added up, and you know one side is length and one side is width. But since there's width on this side, width on that side, and length here, you know that its perimeter equals 2 times the length plus 2 times the width. So what do we do now? Well, if we want to solve for width, W, and we already have perimeter on this side, what we want to do is isolate width. So it's only width on this side and everything else on the other side. So what we're going to do now is minus by 2 times the length on both sides to get rid of this. So those cancel out, and we're left with perimeter minus 2 times the length equals 2 width. What do we do now? We can divide by 2. So we're going to divide by 2 on both sides, and that leaves us with perimeter minus 2 times the length, P minus 2L, over 2 equals W. So that's how we've rearranged the formula to find W by itself. Next, we're going to do a equation you might see in a science class. So we'll do distance equals the rate times the time. Now I want you to notice here that we did RT. If you write any two variables next to each other, you know that they're multiplied together. This is the same thing as writing R times T, R dot T, which is also R times T, or R parentheses T. All of these mean the same thing. Okay, so now what we're going to do is we have D, but what if we want to solve for time? What do we need to do? We need to isolate T. So we're going to divide by R on both sides. It'll cancel out here, and we are left with D over R equals T. What if we want to solve for R, rate? We're going to go back to our original equation, D equals RT, D equals R times time, and we're going to divide by T instead to isolate R. So those will cancel out, and we're left with D over T equals R. So this is a really common equation you'll see where it's 3 variables and you need to rearrange them to find each one. So next we're going to do another geometry one, but you need to note that when solving literal equations, use the same techniques from Unit 1.1, which is inverse operations, but keep the other variables in your answer. So this time, let's solve for area. Area is capital A, and we know it equals 1/2 of base times height for a triangle. Beautiful triangle right there. So the height will be here, the base will be at the bottom, and 1/2 of that is the area. So what if we don't want to find the area? What if we want to solve for h, the height? What we need to do is isolate h. So we'll start by getting rid of this 1/2. What we know we can do, rather than dividing by 1/2, dividing by fractions, it's doable, but it can kind of confuse you sometimes. So instead, let's multiply by 2 on both sides. So this 1/2 and this 2 will cancel out, and we're left with 2 times the area equals base times height. Next, if we want to get base on its own, let's just divide by the base, divide by the base on this side too. We're left with 2 times the area over the base equals h. So we've gone from having area on one side to having h on one side. Now I want you to note, for all of these that we've done so far, we haven't actually gotten a real number answer. We've gotten h by itself. So we're not solving for a number per se, we're solving for a variable. And if we have numbers, we could use them to solve. Now we're going to do a more complex example. It's going to be the slope-intercept form of a line. So you might see this later in the year for Algebra 1. We know y equals m, the slope, x, which is x, plus b, which is your vertical shift. So if we have y on this side, what if we want to solve for x? What if we want to get x on its own? Well, what we can do is we can minus by b on both sides to start. So y minus b equals mx. And then we can divide by m on both sides. That'll cancel out. And we're left with y minus b over m equals x. Now remember, you can do this for literally any variable in the equation. All you have to do is rearrange in the correct order. I'll show you this by doing m. So to solve for m, it's a similar process. We'll start by minusing by b on both sides to isolate m, so we're not isolating x anymore. So we're left with y minus b equals mx, and this time we'll divide by x to get m by itself. So y minus b over x equals m. This is really important to know if you have all the other variables of the equation, but you don't have another one, but you need to figure out what it is, even if it's not isolated. So now we're going to see one that's really useful just in everyday life. It's going to be the temperature conversion formula. It's going to be F for Fahrenheit equals 9 over 5 Celsius plus 32. So you can see we have some numbers in it, but we're still trying to solve for C. We're trying to get C by itself. So let's start by subtracting 32 from both sides. So F minus 32 equals 9 over 5C. Now we want to multiply both sides by 5 over 9. So to get rid of this fraction, we need to multiply by its reciprocal, which means you flip it. So if you have 9 over 5, you want to flip the 5 to this side and flip the 9 to that side. So we're going to be left with 5 over 9. So let's multiply both sides by 5 over 9, which gives us 5 over 9 F minus 32 equals Celsius, equals C. So this formula can let you convert Fahrenheit to Celsius or Celsius to Fahrenheit. Again, you can rearrange the formula and use whichever order you need it. A summary of the process is, we'll go step 1, and what you want to do is identify which variable you want to solve for. This could be x, this could be y, this could be m, this could be f, this could be c, this could be whatever. But you want to identify which variable you want to solve for. Step 2, You know this. Use inverse operations. So you're solving it backwards, basically. The next steps, 3 and 4, are to keep all the variables in your answer. So we're just going to write keep. And make sure you remember this. You can't get rid of any formulas, variables. So remember back to our y equals mx plus b. This is nothing but variables. There are 4 variables in here. But remember, we have to keep every single one in it. And then finally, step 4 is to check. The variable you're solving for, again, for this example that we have here, we're solving for c. You want to make sure that the variable was by itself. So identify, use inverse operations, keep the variables in your answer, and check that it's all by itself. Make sense? Okay. So, the key differences from this and solving for a number are that your answer will contain multiple variables. You're rearranging a formula rather than finding a specific value, and the same techniques apply. So even though you're not finding an exact number, you can use inverse operations and order of operations. So a tip is when you're solving literal equations, treat the other variables like numbers. If you need to move 21, subtract 21. If you need to move m, subtract m, or divide m, whatever it is. And make sure you always do it on both sides. So now you're done. You have learned how to rearrange formulas and to solve for any variable in a multivariable equation. Make sure you do the homework attached.